we're going to look at something called trigonometry here, which essentially is just ratios. And I'm going to start off with this drawing here. Here we have a triangle, triangle ABC, with the corresponding sides A, B, C. And of course we're using lowercase across from their corresponding letters to indicate the sides. Trigonometry is nothing more than ratios. And we just say, if we're talking about a certain angles, we're not really going to refer to the 90-degree angle, so don't worry about C, but we're more interested in the acute angles of a right triangle and A and B. So for A, what's called sine, which we abbreviate SIN, is actually the opposite over the hypotenuse. In other words, the sine of A is equal to A over C, the opposite over the hypotenuse. And so in fact, sine of A would actually equal A over C, whatever those numbers are. The cosine of A would equal the adjacent. Adjacent meaning beside. Now when we say beside, we don't mean the hypotenuse, because that's already labeled the hypotenuse. We mean the other one that's beside, which is B. So in this case it would be B over, and of course the hypotenuse is C. The last one here is the tan of A, which equals the opposite, which would be A, over the adjacent, which we already said is B. So this one would be A over B. We could do this also for sine of B instead. And so if we chose sine of B instead, I'll just go through these ones down here at the bottom real quick. And the sine of B, okay, would equal, well, it's always opposite over hypotenuse. But in this case, opposite would be B, and it would be over C. So it's a little different than sine of A. You can see it changes the ratio. If I'm talking about the cosine of B, if I'm talking about the cosine of B, it's going to be the adjacent over the hypotenuse. So in which case it'll be A over C. And of course the tan over, the tan of B would equal opposite, which is B, over the adjacent, which is A. So you end up getting this. There are handy ways to remember these opposite and hypotenuse and adjacent things. And it's something called Sohcahtoa. A lot of teachers use this. It basically just means that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Just a handy way to kind of memorize these. Let me show you how to use all of these functions here, and you're going to have to memorize these. But let me just show you how this works. If I, first of all, make sure your calculator is always in degrees. But if I do this here, I'm going to have like something like this. So let's say I have a triangle, and it's a right triangle, and I'm going to do the same thing here. Actually, I'm going to make these both 45 and 45. Okay. We could say that the tan of 45 is going to equal something. I could punch this in on my calculator, and you'll get a number. But if we look at this one here, well, I'm just going to make up numbers here and just say, well, that's 6, which means this is 6. And of course, this is 6 root 2. We learned that from before. But knowing the tan of 45, well, if I look at 45, opposite over adjacent, in which case would be 6 over 6, which is 1. It doesn't matter if I start with this one either. Tan of 45 will still equal 6 over 6. If I punch this number on my calculator, I will actually get the number 1, which means I can know the ratio of these two sides without knowing the triangle just by punching in tan of 45. It'll give it to me as the number 1. You can do something else here and just show that if I look at something like 30 degrees, okay, and 60, and I look at a triangle like this, and suppose I said that this number is 4, okay? Well, because it's opposite of the 30, this number has to be 8. And of course this will be 4 root 3. But when I look at this one here, what if I wanted to find out what is the sine of 30 degrees? Okay, the sine of 30 degrees I could punch in my calculator. But I'm not going to do that just yet. I'm going to look at it like this and say, well, the sine of 30 would equal the opposite, which is 4, over the hypotenuse, which is 8. And of course, 4 over 8 reduces down to 1/2. And in fact, if I punch in my calculator sine of 30, I will get 1/2, or 0.5, on my calculator. It's a very handy way of dealing with this. We can take this a step further and look at certain problems with doing trigonometry, and they look something like this. Okay, you might get angles that aren't the nice 30, 60, 90, but you might get something like this. And I might say that this is, let's say, 40 degrees. Okay, and knowing that this is 40 degrees, maybe this is 50. We know this stuff. What I might get is something like, well, you're going to get x. Let's say we want to find this, and I know that this is 12. Knowing this, okay, what I can do is to say, well, what trig function involves both of these? Well, it doesn't involve the hypotenuse, so it has to be tan. And I'm going to say here, it doesn't matter which one you choose, but I'm going to pick 50 here and just say that the tan of 50, which is some number, I can punch that on my calculator, that would equal the ratio of x over 12. In which case I can say here now that x then has to be equal to 12 times the tan of 50. And it's a nice handy way of figuring out what is x without using Pythagoras, because I can't use Pythagoras because I don't have all the sides. It's another way of doing that. You could have another triangle here that maybe looks like, I'm going to make this 37 degrees. There's a right angle. And say we know these two, and of course you can figure out this angle, but that's not what we're after. Suppose we're after this. I want to know the hypotenuse. But I do know that this side is 15. Okay, knowing that, what trig function would I use? Well, I'm going to use sine here for this one. And it's going to look like the sine of 37 is going to equal the opposite over the hypotenuse, which is going to be 15 over x. Again, I look at it like this because I'm using sine. The first thing you have to choose is what to choose, because I don't know the adjacent side. I know nothing about it. So I can't use tangent, which involves adjacent, and I can't use cosine. So I'm going to choose sine because it's opposite and hypotenuse. That's what they gave me. Now to solve this, be careful when you solve these. It's going to become x is equal to, it's actually a two-part step. Let me just show you how to do that. I'm going to multiply both sides by x, in which case you're actually going to get x sine 37 is equal to 15. And the last step here is that x is equal to 15 divided by sine of 37. And again, this is some number. You can punch it on your calculator. Just be careful how you're punching it in, and always make sure your calculator is in degrees.